Hello everybody. In this video I'm going to show you how to solve the quadratic word problem number 4 from the paper I gave you. So the digit sum of a two-digit number is 9. By swapping its figures we obtain a new number. If this new number is multiplied by the original number, their product equals 2430. So what is the original number? There are a couple of facts we have to realize, and some of them are coming from the assignment and some of them we have to realize based on the knowledge how the numbers are constructed. So the first fact is that we have two-digit number, and the two-digit number can be represented like xy, where x stands for the first digit and y stands for the second digit. Then we know from our assignment that the sum of these two digits is equal to 9. Now comes a little bit tricky thing, and we have to realize that our two-digit number xy can be written like 10x plus y. Where is it coming from? So let's have a look, for example, on number 81. Number 81, based on this expression, can be written as 8 times 10 plus 1. So it is 80 plus 1, and it is really 81. So this expression is really representing two-digit number. Okay, let's take another one. 63 is 6 times 10 plus 3, which is 60 plus 3, and it equals really 63. Now, another fact that comes from the assignment is that if we swap the figures of the original number, what basically this means? It means that my number will be changed to number yx, and this number then can be written like 10y plus x. So for example, let's take 63 and we change it, or we swap the digits, so the number is now represented as 36. What is y in this expression? It's number 3, so 3 times, you can see it here, 3 times 10 plus what is x? X is 6 in this case, so it is 30 plus 6. So my number is 36. So this expression is really true. And as you can see, I swapped the digits here and everything works just fine for me. And the sum of the digits is really number 9. Another fact which is important here is that if we multiply these two numbers, the product is 2430. Now we have to combine somehow this information and put them into this equation. What can we do here is we can say from this equation that y can be represented as 9 take away x. Okay, and as we have y here, we can simplify this expression, or basically this expression, and we can represent our xy number being 10x plus, and I will put brackets now so that you can see clearly what is happening here. And if you simplify this expression, my two-digit number xy can be represented as 10x plus 9 take away x, which is 9x plus 9. So for example, let's try and let's prove on our number 63. Our x in this two-digit number is number 6, so 9 times 6 plus 9 should be 63, and 9 times 6 is 54 plus 9, which is equal 63. So this expression is really true for my original number. And if we apply the substitution coming from the first equation to the second one, then my two-digit number with swapped digits can be written like 10 times 9 minus x plus x. If we simplify this expression, we will get 90, take away 10x plus x, and it equals 90 minus 9x. Okay, so this is my first expression, this is my second expression. Let's have a look. We swapped the numbers here, so 36. In this case, as we have yx order of the digits, x in this case is number 6. So 9 take away 9 times 6 is really 90 minus 54, and this is really number 36. So everything fits. We really have the expressions which represent the situation we are trying to solve. So there is nothing easier than to replace these two factors in this multiplication by the expression we got. So this is my first expression for xy number. So it must be true that 9x plus 9 times, and this is my second expression for the number yx with the swapped figures. So times 90 take away 9x equals 2430. And now it's very simple. 9 times 90 is 810x plus 9 times 90 9x 90, yes, 9x times negative 9x is minus 81x squared. Now 9 times 90 is 810, and 9 times negative 9x is negative 81x equals 2430. Let's simplify this expression on the left side of our equation. So as I always wanted the quadratic term being the first, it becomes like negative 81x squared. And now 810 minus 81x becomes very hard to calculate from hand. So 700, and it's like 70, so I think it's 29x, plus 1 is 730, plus 80 is, yes, 100, so it's correct, and the rest is 110 equals to, everything is yeah, here is negative, here it's positive, okay, 2430. Now let's take away 2430, so my equation is 81x squared plus 729x minus, and I'm sorry, I'm quite lazy for calculating this and I don't want to make a mistake, so it's 2430 minus 8110, and it's 1620 equals 0. As I don't like a negative sign in front of my absolute term, I will multiply my equation and it becomes 81x squared minus 729x plus 1620 equals 0. Now I'll show you some tricky thing, and if you will stop using your calculators, you can very easily come also to this procedure. Before I start calculating the discriminant, because we are now training the discriminant or quadratic formula, I would try, and you'll see that it makes really very nice and it will simplify the whole equation. And what I am looking for is if I can divide or if I can multiply my equation by 1 over 81. So let's try. We know already 81 times 1 over 81 is 1. But is it also 729 divisible by 81? So let's try. 729 divided by 81. and look at this, it's number 9. So if we simplify, it's x squared minus 9x plus, and the only thing which now is tricky is 1620 divided by 81, and guess, is it gonna be divisible? Hooray, it is. And it gives me number 20. So instead of calculating very complicated numbers, I became to very easy quadratic equation. And now if you look at this quadratic equation, it can be solved even by factoring, because I have really like nice numbers, -9 and 20. So let's finish calculating by calculating discriminant. So discriminant is b squared minus 4ac. It is b squared is -9. I will provide the whole number squared, minus 4 times a is 1 and c is 20. Instead of writing this, I think you can really be fast now, because you know how to calculate. So -9 squared equals 81, minus 4 times 20 is 80. Good news, my discriminant is equal to 1, so it means for the first that there will be 2 real roots, and that I can really calculate very easily my roots, and it looks like it will be really nice numbers, which is good news. So let's calculate my roots. x12 equals -b plus minus square root of d divided by 2a, and it equals 9 plus minus 1 over 2, which means my first root is 9 plus 1 is 10 divided by 2 is 5, and my second root is 9 minus 1 is 8 over 2 equals 4. So these are my 2 roots, and if I'll come back to this substitution here, I can very easily calculate the y of my 2-digit number. So let's do it this way. I will use it here so that you can clearly see. Now I will calculate my y. Actually, what are we expecting? What would be the situation here is 9 minus 5 equals 4. So these 2 digits will be simply swapped, which is quite clear why, and you can think about it. So my y2 or second y for second x would be 9, take away 4, which is 5. Okay, so my 2-digit numbers, or number, because basically, yeah, numbers, there are 2 numbers, x, y. So my original number can be now constructed like x equals 5 and y equals 4. So this is my first number, and the second solution can be 45. So if I swap the numbers here, my yx will be 45, and here my yx will be 54. So now I'm supposed to do the check. Let's take the first pair of numbers, 54 times 45. So this is 22, this is 27, so this is 16, 1, so this is 21. The sum of these 2 numbers is 3 and 3, yes, 1, so this is 3, 4, 2. Okay, so I'm done here. Everything should be clear. If you didn't understand anything about the video, watch it like 2 or 3 times. It doesn't matter, depends on your preferences. Thanks for watching. Bye.